so long ago, in a land by the name of Middle Tennessee, a league of high school students came together to form a team to compete in the great quest known as the First Tech Challenge. They dubbed themselves Team RPG. The great team divided itself into two portions. The first of these, the noble engineers, created the body of Team RPG's great beast, Bayorn.
Well, I'm going to talk about the wheels. As you can see, our wheels look kind of ridiculous. These are Mechanism Omni wheels. Basically what they allow us to do is to strafe side to side, go forward, backward, and pretty much any two-dimensional direction we want to. We haven't worked out the flying yet, but they give us an edge in the competition where we can align ourselves very easily against the moving components. So in the back here, we have something we like to call the goal capture. This spins down to capture our pentagon-shaped bowling goals. These straighten it so that we can get it perfectly in there. This grabs the hole, and then our actual system of dumping the balls in is perfectly aligned so that the balls can fall in the tubes when it's caught here.
So we score balls in the goals using a drawer slide lift. We have several drawer slides here, and a wire is running through them, and it's attached to a motor, and we crank the motor up and it raises and lowers. And this is also attached to a bucket, which we have a spinner up here that brings the balls in. If you'd like to see a little bit better, you can kind of see it in there. It's about there. So basically, this is it, and this is the motor that powers it. And as you can see, it's attached to the wire. So.
What kind of wire is that? Sorry to interrupt. Jackson, what kind of wire is that?
Oh, it's stainless steel. Either it's wrapped or it's.
That's fine.
Yeah.
Sorry.
We've gone through so many of them.
Yeah.
It's hard to
It's fine.
remember.
Okay, this is our ball collection mechanism. As you can see, it uses a spinner with zip ties that are screwed in. It also, to keep the robot within the 18 inches, it folds out. This little thing, in autonomous, this flips up, and when the robot moves, it kind of makes this thing fall out. Oh, and when it launches the balls up the ramp, and they kind of jump up here and land on this.
Okay, so this is. I'm gonna talk about something very minor, but it's the Anderson power tools, and they clip together and they stay together, which is different from the other ones. And we use, instead of using one line, we used a bunch of extensions in this. Keep the servo up here.
There's a servo attached to the bucket that lets the balls fall out.
You might be able to crank it up.
Yeah, let's see it in action.
Just hold it.
Yeah. Just keep the wire. Okay.
Oh my
And then
gosh.
this servo flips out. Can you see that?
Yep.
Okay.
You might have to put around because
Yeah.
Yeah, I see. Yeah, I see.
Can you see?
And the PVC pipe, this is half a PVC pipe that kind of serves as a guide for the balls.
Yeah.
We actually got the idea for our drawer slide thing from the team that you just talked to, the brown coats.
Oh, okay. Yeah.
Like I said again. But Bayorn was not complete. He was only body, he had no mind, and thus the engineers searched among themselves to find a member they thought worthy enough to bring it life. Finding none, they turned to the erudite programmers to create his soul.
When we first started building the robot, there wasn't a whole lot to drive or to program, so we didn't exactly want to just sit around doing nothing while waiting for the engineers to finish with the robot so that we could program it. So we started programming using this. We call it BabyBot. It has an NXT break just like the one that we're using. However, we didn't want to have to change all of our programs. We didn't want to figure out the logic and then just have to rewrite our entire programs using that same logic. So instead, we wrote our programs pretty much only using functions. That way we could have two separate function libraries. One we call it four-wheel movement, one we call it two-wheel movement, even though they both have four wheels. This one has four-wheel motors, and that one only has two. But basically, all of the functions have the same names. Like four-wheel movement has a forward function, as does two-wheel movement. So basically, we can just switch out which function library we include, and that lets us switch between robots. We wrote pretty much our entire first autonomous program using that small robot. We also use GitHub, which is a version control repository, to make sure that we have the same version of code on all of our computers, and also so that if anything goes wrong, we have a record of all of our previous versions, and we can just go back and to the last time it worked. And we also use lots of sensors, less than we used to, but we still use a fair amount. We use an IR sensor right here to figure out what position the figure out what position the center goal is in, and use that to knock over kickstands, score the center goal, stuff like that. This one right here is a gyro. We use it to make precise turns. We also use a touch sensor down here underneath the bucket that you just saw raised. That makes it so that our lift doesn't go too far down and strain the motors. Basically, once it hits the bottom, if it touches the touch sensor, then it will go no farther down and it'll stop until it's told to go back up again. And finally, we use motor encoders a lot. Whenever we're doing any type of autonomous programming, we want it to go exact distances, but we didn't want to just do time because that depends on how strong the battery is, stuff like that. So instead, we wrote a few functions that convert encoder values into centimeters. They don't come out exactly as centimeters, but we call them RPGs. And then we can just type in a number in RPGs, and it will travel forward that distance. We have put quite a bit of thought into our programs and lots of logic and hard work, and we're hoping that this qualifies us for the control award. And there's actually another copy in the engineering notebook.
Perfect.
See, thank you.
After the team created and brought Bayarn to life, they realized that it was their duty as FTC Crusaders to roam the land of Tennessee, educating others to the opportunities and great joy that it is to be an FTC. So they began to reach out to their community and neophyte FTC teams.
One of the most important aspects of FOST is outreach, because if we only gain knowledge and don't give it to people, society as a whole cannot build. Knowing this, we went out and done many FTC outreach events, some of which are some few of the school STEM fairs in our area. We did an FRC tournament display. We went to the Mini Maker Fair, Nashville, at the Adventure Science Center, and that's where we picked up Jackson. We did stuff with the Adventure Science Center 3 different times for 2 elementary-aged summer camps and a high school camp, robotics camp. We also went to the Spring Hill Library earlier in the year to talk with a family there who we got them into starting up a team who participated in the Monkey Madness
The Huntsville qualifier.
Monkey Madness's Huntsville qualifier.
Sure.
And yeah, the name is Shot.
They also participated in Kentucky State Tournament.
We hosted PTC representatives. We helped start up the Hoppeth Hall team in Tennessee, and we've walked with them a lot, just talking with the coaches, preparing them for their tournaments. We also went to the Wilson County Fair, which is the 7th largest fair in the U.S. A few of us taught a robotics class at 4-H Club. We went to the ENIAC Science Fair. Last year, we were the only competing team in Tennessee. Now there's 7 in Tennessee, all of which we have direct ties to.
And all 7 of which were at the Huntsville qualifier.
Yeah. Also being in person, including going to events in person, we also have our website, www.teamrpg.com, where you can link to our different sites, including our YouTube page and Facebook page. We also are having 3 upcoming FTC opportunities. There is in Tennessee, there's the Adventure Science Center Engineering Day, Adventure Science Center and Wilson County Southeast Branch Easter Egg Hunt, and the PTC Live Global Conference. Excuse me. And here are more details on that.
So are you all a school or a homeschool or community organization?
All around. We meet at his
At one place, okay. So you have to go to different schools and stuff, okay.
We're mostly homeschooled, but we're not directly tied to any homeschool tutorial or any schools or anything like that. It's an independent team.
So y'all just got together and formed a team,
We're an
basically?
individual team.
Okay.
You can see here a bunch of our sponsors we have on the back of his t-shirt and everybody else's t-shirt. Everyone else is wearing a costume. He refused to, so he gets to do this.
Boring.
Too good for it.
That is a big part of our team, I guess, because we don't have any specific place to meet or anything, so we ask for donations a lot of times, and this is where we got those.
Y'all practice how much?
We meet at least twice a week.
Twice a week.
And before competitions and outreach things, we meet 3 times a week.
It's a minimum of 6 hours a week, but people tend not to leave until like several hours
Right.
afterwards. So.
Once you get into it, that's it. Nobody leaves,
They
they
don't
kick
lock-
you out.
They don't lock their house anymore.
Do you guys, you mentioned that you have specific titles and roles. Do you ever do any crossover work?
Not much. We do a little bit. I've been doing a fair amount with the engineering lately just because I think it's fun. Basically, the engineers have a fair idea of the logic that goes behind the programs, and then the programmers have a fair idea of the structure of the robot, but programmers tend to not have an intimate knowledge of how the engineering mechanics work, and the engineers don't know the syntax or what the code actually looks like.
Okay, thank you.
All right, we don't have much time left, but my real only question for you guys is, who came up with the strategy for this robot? Who came up with the design for it? Was this a team decision? You said that the mechanical engineers or the engineers don't get the programming, and the programmers don't really get the design aspect of it. But somebody had to come up with the idea of, well, we're going to make it go this high and drop the balls like this, and then we're going to grab the goals. So who comes up with that idea?
Well, there's this shed, and we all go in there, and we just brainstorm.
So it's a team
Yeah.
collaborative
They
concept.
We have the field set up
Yeah.
in the shed.
Like one of those big wheels that we just spin and see what it lands. It's very much a team decision.
Yeah.
This week, like I said before, we did get this idea from Browncoats. We kind of social media stalked them and found pictures. That was my job.
Generally, when we have an idea, generally we'll make a sort of a prototype of it, and generally if we have multiple possible designs, we'll vote on which one we try first. Sometimes that comes out with a design we end up using, sometimes it doesn't. Like we had,
Would you like to talk about the Scissorwood Park?
Is
You don't have much time.
yes.
Take it
Yeah.
apart.
I don't know if we
We had a scissor lift and we had a sled lift to try to remove, and then we decided against them.
We started with a solid steel scissor whip,
Terrible
which weighed
idea.
like 100 pounds.
I like that you brought it.
It's not
we
even working
killed
now.
the scissor
Yeah.
lift.
That one's aluminum, doesn't stand like 5 pounds.
We do actually draw everything out before we make it.
Yeah.
I just want to make that.
Yeah.
And it doesn't work.
We just don't necessarily know if it's going to work just by drawing it.
Right.
Do you guys use any CAD?
Jeremy's kind of our cat expert.
We we've printed some parts before. They've never made it onto the robot yet, but we've printed some parts for designs.
What CAD you use? PTC?
Autodesk.
Autodesk, okay. So y'all have y'all printed any 3D printed parts to
Yeah,
it?
we
You said that's right, you did, you said that.
yeah, for one of our designs, we actually had these little plastic things that were supposed to help with the friction, but they were a little too flimsy because they were 3D printed.
Right, okay.
It was with our slide lift.
Yeah.
We were all sitting on the couch sanding them,
And we sanded them a little bit too much.
and then they didn't make it on the robot. It was very sad.
A lot of hard work. Yeah, I'm great too.
Good luck to you all.
Thank you.
Yeah, good luck to you
Thank
all.
you so much.